Hello everyone, it's Sean Whiteford here, President of NEXMs Mining Corp. We thought we'd put together a short presentation to further explain the results and implications of our July 28th press release on XRT ore sorting. First, some basics on XRT ore sorting. Another way to think of it is pre-concentration. We want to maximize the metal, or in this case, copper, nickel, cobalt, and PGEs, sent to the concentrator and minimize the amount of waste. This recovers metals more efficiently, reduces costs, and improves sustainability. So let's walk through a typical XRT ore sorter. On the upper left, crushed ore is fed by conveyor to the XRT machine, where it passes through a sensor computer the computer identifies the ore and the waste, and it moves along and is ejected by air blast into separate piles, one being waste and one being ore. The sensor looks at the material, and here's a typical core from Saleve. So we have a mixture of ore in gold and bronze and waste in black. So once this is crushed up, the XRT can say, well, the black stuff we're going to leave behind, and the ore we'll kick out into another place and take that to the surface. Here's some photos from our underground bulk sample at Saleve. So we can go and blast material, which would be typical as a mine operation. And then we take that and we crushed it on site and sent that for testing. As you can see here, in the bottom left, there's a lot of waste mixed with the ore. So what does that mean for Saleve? How would we use it? Well, one of the benefits of a long mine life is they left behind 25 plus years of open spaces. So we can position the XRTs adjacent to the mine shafts, adjacent to a crusher, and when they split the waste and the ore, the waste will go into the underground voids and the ore will go to surface. This has the effect of maximizing our hoisting capacity because we're leaving the dilution of the waste behind. Finally, some words on the results. We achieved 15.2% waste rejection, which is when the XRT sorted material was combined with the fines. When you crush material, you produce amount of fines and coarse material. The XRT takes plus 12 millimeter, and the fines are considered minus 12 millimeter. If we look at the results when we just the plus 12 millimeter, the results are quite a bit better. The ore rejects are 28.4%, meaning instead of 15.2% waste rejection, it's 28.4%. And the enrichment ratio, or increasing the head grade, was 34%, and we still achieved 96% recovery. So that is the goal of our current program, is to get closer to those results. Let the XRT do its work and work its magic. Thanks for watching. We are going to include a link to a XRT sorting video produced by Comics, and I hope you enjoy it.